Hello friends, today we will discuss about the second tutorial of DESMOS. If you have not seen my first tutorial, then I suggest that you please see my first tutorial. It is there in my playlist. In this second tutorial, we will discuss about the restrictions, regression, summation, tangents, trigonometric functions, parametric equations, polar graph, etc. kind of topics. So the first topic that we want to see is on the topic restriction. So what is restriction? Actually, suppose if I want to draw a parabola, that is I want to graph a parabola y is equal to x square minus 1. This is a parabola. Let me zoom in. This is a parabola. Now suppose in this parabola I want to see only those parts of the graph in which y is less than 3. So I am writing in the curly brace the condition. This condition is actually the kind of restriction that restricts the graph to this condition such that when y is less than 3, then only this graph will be displayed for that points only. So this is a kind of specific condition. Suppose I want to add another restriction on x saying that x greater than 0. So this is that part of the graph in which y is less than 3 and x is greater than 0 for the given parabola y is equal to x square minus 1. Similarly, suppose this is a sine, y is equal to sine of x. This is a sine function. In this sine function we added a restriction saying that 0 is less than x is less than equal to 2 pi. So only from 0 to 2 pi the sine function is being displayed. Suppose this restriction was not there, then what happens? This sine function is displayed from minus infinity to plus infinity. That's why the restriction is given to view only the specific area of that function. I hope this topic is clear. Now we will move on to the next topic. The next topic is on regression. For regression we need some set of data points. These are the set of my data points. That is set of x and y values. So I copy it and directly paste it over there. So these are the set of data points, that is x and y. For each individual x and y, the points have been plotted on the graph. Now we have to do the regression. Regression is a kind of approximation in which we try to find out a polynomial that will approximate this path of the given points. So suppose for regression we can choose any kind of polynomial. So let's choose the basic polynomial. The basic polynomial is the polynomial of degree 1 or the polynomial that is called the straight line. The polynomial with the degree 1 is called the straight line. So we will do the regression with using a straight line. Let's see how it is done. For doing the regression, we will write y1, then we will give the tilde symbol. This tilde means to regress against the given set of data points. So this tilde symbol will be given and we will use the equation of the polynomial with the degree 1, that is the equation of the straight line, that is mx1 plus b. So after doing the regression, as you can see over here, that the set of data points are given. These are the data points that have been plotted and the straight line is passing through these data points. Now all the data points are not on the straight line. There are some data points that are above the straight line and some data points are below the straight line. So how is this line passing? This line is passing in such a way such that the distance from each point to the line is minimum, that is the error is minimum. Hence by the condition of minimum error, this line is passing through all the points such that the error is minimum. But this is not a good approximation, we can say, as all the points are not coming under the are not touching the line of the polynomial for the regression. So what we will do, we will increase the degree of the polynomial that we have taken for the regression. Here we have taken the polynomial of the degree 1, that is the straight line. Now we will take the polynomial of degree 2, that is a quadratic polynomial, quadratic equation. So what we will write over here, instead of mx1 we will write a x1 square plus b x1 plus c. So this is a quadratic polynomial whose degree is 2 and it is seen that it is passing almost through all the points touching. That means it is giving a better approximation in comparison to the previous approximation. That means in this the error percentage is less. What is error percentage? Error percentage is the deviation of these points from this graph. So if I zoom in so much, I can see that these points are actually not on the graph. They are either below or they are either above it. But still it is after zooming so much. So the error is very negligible and we can neglect the error, and so we can consider that this approximation for this given set of data points, by the quadratic polynomial is nearly accurate, we can say this. So this is how a regression can be done. Now the question is, y1 is equal to ax1 square plus bx1 plus c, that we have assumed. So what is the value of a, b and c? A, B and C are calculated by the software. There are several algorithms like the Lagrange interpolation and other kind of algorithms are there. So by that the A, B and C values are calculated, and they are put in this A, B and C, the values are put, and this polynomial is plotted by the software. So such that all the points lies in the close proximity of this given graph of the polynomial, such that the given graph of the polynomial used for the regression passes through the given points. So this is how a regression is done. Suppose I want to see the amount of error for each point, then what I will do, I will click on the plot, that is residual E1, I will click on the plot, and I can easily check by clicking on this point. So the y's value for this point is minus 0.034. That means the error for this point is minus 0.034. That means this point has deviated from this polynomial's graph by minus 0.034 units. So similarly for all the points the error can be calculated like this. The y values correspond to the error. This is regression. I hope the regression is clear. Now I want to show something about summation. How to do the summation function. Suppose suppose I want to plot y is equal to sine of x. This is the sine function I have plotted. Y is equal to sine of x. Now by the Taylor series expansion, we know that the expansion of sine x in terms of Taylor series can be expressed as y is equal to summation. For summation we will write sum sum, n equal to the lower bound 0 and the upper bound I will put as a constant a, which will be changed by using a slider. So by the Taylor series expansion I know that sine x can be written as summation from n equal to 0 to a. It is minus 1 raised to the power n, sorry, this is minus 1 raised to the power n x raised to the power 2n plus 1 and in the denominator it has to be written 2n plus 1 factorial, 2n plus 1 factorial. So this is the formula, this expression we got from the Taylor series expansion of the sine function. So the Taylor series expansion of sine will give me this expression. So for this a, which is a constant, I add a slider. This slider is going from minus 10 to 10. I will neglect the negative part because we don't need the negative part. So I can say it should go from say 0 to like assume it is going till 20. Okay, the step size I will not decide. This the software can decide on its own. Now see what is happening. By default the value of a is 1. So in this Taylor series expansion formula of the sine x, we are having we can say that n is starting from 0 and going to 1. So there are if we neglect the 0 term, so there is only one term. So when there is only one term after means if we neglect the initial the 0 term, there is only one term, the first term. So when a is equal to 1, the approximation made by the Taylor series expansion of sine x is from this point to this point. That is, the approximation area or the approximation range is so small, and after this range you see how the Taylor series function is getting deviated from the main sine function. So in order to increase the range of approximation, what we do, we add more and more terms to the Taylor series expansion of the sine function. In order to increase the approximation, in order to make the approximation more clear by the Taylor series expansion of the sine function, we add more and more terms to the Taylor series expansion. So how we will add more and more terms? In this the a value we will change. As the value of a will change, more number of terms will be get into the summation and more number of terms will be included, and such that the accuracy level or the approximation level will increase. Let's see how. I am little zooming it out. Now I will just make it autoplay. See, as the value of a is increasing, the approximation level is also, the approximation area is also increasing. See, when a is equal to 10, then this Taylor series expansion of sine x can approximate the actual function sin x from this point to this point, that is the area of approximation has increased. So as we will add more and more terms, it will approximate, its approximation will go on increasing. But the limitation is we cannot add infinite number of terms. This is the limitation, because after certain range, like suppose I added 10 terms, so after the 10 terms means from the 11th term you can say, or from the after this point, you see how it's getting deviated, means the Taylor series expansion when plotted is getting deviated from the main function. So this is how we use the summation feature of this DESMOS. Now the next we will discuss about the tangent lines. We will discuss about the tangent lines. This is y is equal to sin x, the graph of sin x. Now what we will do, instead of y equal to sin x, we will assume a function to be equal to sin x, that is f of x is equal to sin x. Very good. Now after this, what we will do, we will assume another function gx such that gx is equal to d by dx, that is the derivative of the given fx. So gx is the derivative of the given fx. Now we don't want to display the gx, so we switched it off. The sign is getting displayed, very nice, but we don't want to display the gx, that is the derivative of sin x. Now what we will do, we will add a tangent point. The tangent point can be added by using an ordered pair c comma f of c. So this is a tangent point. If I add a slider to it, you see, if I move the slider, this point is moving along the curvature of the sine. So this is actually this is the tangent point. We will find the tangent of the curvature of the sine curve at all these points where it is moving. So this point is called the tangent point. So what I will do now next, I will write the equation of the tangent of this given curve of sin x. So how I will write the equation of tangent? We know from the straight lines chapter that y minus y1 is equal to m x minus x1, where m is the slope of that given function at any point. So here the slope is equal to the derivative of that function. We know that slope is equal to derivative. So here I will write y is equal to g of c, because I want to find the slope at c, because c is the tangent point. So g function is the derivative of the given sine function. Since g is the derivative, so g of c will give me the tangent of the sine function at the point c. So I got the g of c will give me the slope of the tangent. Sorry, I said wrong, I think. So y equal to g of c will give me slope of the tangent of the sine function at the point c. So g of c is the slope. Here I will write x minus c, and here I will write plus f of c. So as soon as I press enter, you see a straight line has appeared. Now this straight line, as I move the point with the curvature of the sine, you see this straight line is also showing some activity. So what is happening? At this point, see this, at this point, whatever the value of the slope is, this straight line is having that same value of slope, because this straight line is the tangent of this given curve at this point. So this tangent, so this is how a tangent line is plotted. Now this portion is having the slope of the tangent as positive, and this portion is having the slope of the tangent as negative. When the slope of the tangent is positive, we can say that the function is increasing function, and when the slope of the tangent is negative, we can say that the slope of the function is decreasing function. So this is how the increasing and decreasing functions can be calculated. If the slope of the tangent is parallel to the x-axis, that means the slope is 0. This tangent is parallel to the x-axis, that means the slope at this point is 0. So if I make it autoplay, you see how the tangent gets differ at each point of the sine curvature, because of the slope is changing. Yeah, this is how. Now the next thing that we will discuss is some trigonometric graphing. So let me just close all this one. So we will discuss about the trigonometric graphing. So for this, Like suppose if I want to plot y is equal to arc cosine, means arc tangent of cos, that is arc cos x. This is that function. Then suppose if I want to plot y is equal to tan of x, then this is that plot. Suppose I want to plot y is equal to sin h of x, and this is that y is equal to sin h. Suppose, sorry, I have written sin g, it is sin h of x. Now suppose I want to plot some parametric equations. So let me close all this. Now if I want to plot some parametric equations, like say cos t comma sin t, this will plot a circle cos t comma sin t. Now since it is a parametric equation, it is asking the values of t, that is the range. So I will give 0 is less than equal to t is less than equal to pi. So if I give this pi, is giving me a semicircle. Now if I make it 2 pi, it will give me a full circle. You are seeing it oval because the grid lines are not perfectly square. So I have to make it square. So for making it square, I have to come over here, and here also the step size should be chosen as pi by 4. Then it will become square. Now see, it has changed into square. Maybe the grid lines are making some problem. Okay, let's do it in the different graph. Suppose I do it over here. Suppose I write ordered pair cos t comma sine of t. So asking the values of t, that is from 0 to pi. So this gives me a circle. Here also the same problem actually. The boxes are not so perfectly square. I have to make the settings, and suppose if I make it 2 pi, then this becomes a circle. Let me open a new graph. This is perfectly square. So here cos of t comma sine of t, and here if I put the values like 0 to pi, so this is giving me now a perfect circle because the grids are arranged in perfect square. That is why. Now if I make it 2 pi, it gives me a perfect circle. In pi, that gives me a semicircle. 2 pi. So the next that we will see is ordered pair. These are all kind of parametric equations. Okay, so ordered pair 4 sine 4t comma 3 sine 3t. So what is happening in this? From 0 to 2 pi, if I go 2 pi, and if I zoom out, you just see this kind of pattern is drawn. Such a beautiful pattern. So this is how a polar equations can be plotted. Very simple, not much problem. Now suppose if I want to do the polar graphing. Suppose I want to make the polar graph. So for that, what I will do, I will go to the settings and I will choose the grid as polar. Okay, now this is the polar grids. Now I will do the polar graphing. Suppose I put r equal to 3. I put r equal to 3 and the value of r will be from the slider. So if I press enter, so as this is increasing, the radius of the circle will increase, and as this is decreasing, the radius of the circle is decreasing. So what is this? This r equal to theta, sorry, this r equal to a constant is a circle. Now suppose I write r is equal to 2 cos theta plus 1, say 2 cos theta plus 1. So this gives me this kind of shape from 0 to 2 pi. You see, this is this kind of shape. Now suppose if I, instead of saying 2 pi, if I added 4 pi, then also that same shape is appearing, but the pointer is revolving twice. That is why the line you are seeing is much deeper. So instead of 4 pi, if I put 6 pi, it will be even more deep because it is repeating 3 times on that same path. Anyways, so y is equal to 2 pi. Now the next that we will see is r is equal to 5 sine theta theta. R is equal to 5 sin theta. This gives me a circle on the x-axis, on the horizontal axis, touching 5. A circle of radius 2.5, it can be said, but I don't know what is actually the radius of this. Actually, I am not sure on this. What is the radius? So R is equal to 5 sin theta. Then suppose if I make it 2 theta, then this becomes something like this. This is a kind of experimentation that is going on. You see, for R equal to 2 theta, it is giving me like this. For R equal to 3 theta, there are 3 blades. For 4 theta, so many, or 7 theta, sorry, for 4 theta, it is like this. For 5 theta, like this. So suppose I add a slider on it, like if I say n theta and add a slider for n, what will happen if I keep on increasing this? See, this kind of pattern is making if I keep on increasing. Suppose I make it autoplay. For different values of n, different kind of patterns are increasing. Let's do it manually. See, for n equal to 6.8, so many patterns come. For n 6.5, there are so many difference. And this is n equal to 6. And what about n equal to 7? This is n equal to 7. But in between, when there are decimal values, so beautiful patterns are coming. These are some beautiful patterns. Now suppose I write R is equal to cosecant CSC cosecant of theta from 0 to 2 pi s. So in the polar coordinate that is getting plotted. However, we don't use such type of functions in mathematics for class 11 and 12. We generally don't use. R is equal to sec theta. If I plotted R is equal to secant of theta. Yeah, these are giving the straight lines. So this is how the polar graphing can be done. The best is this one, R is equal to 5 sin n theta, and changing the values of n, getting different patterns. Now we will see about some inverse and symmetry of function. Like a symmetry of function, suppose if I want to say, these are very important topics if we consider it in the +2 point of view, that is 11 and 12 point of view. These are very important topics. Suppose I write y is equal to x square, then this is an upward parabola. Very nice. Now suppose in the next I give, for suppose if I replace x with y in this given y equal to x square, y is equal to x square, suppose if I replace x with y, then what will happen? Then x is equal to y square will come. This is just the same parabola with some different orientation. First the parabola was on the, it was means it was sloping up, means it was upwards parabola, and it was y is equal to x square, that is negative y was not there, and this is x is equal to y square. This is the rightward parabola. So let's see the angle of symmetry, means where it is getting symmetry, means where it is having the same angle of symmetry, how it is changing the line of symmetry. Let's see that. So here I will write y is equal to x. So this is the straight line from where it is getting reflected, if I can say in the terms of symmetry, it is getting reflected from that point. Now suppose if I add here bx plus c, and here also bx plus c, and if I add sliders for both, and if I make it autoplay, so along with the values of a and b, this is changing. So this is how the orientation of the function changes when we replace x with y and y with x. The same can be done. The same can be done with say y is equal to like f of x is equal to sine x. This is the sine function, and x is equal to f(y). If I write x is equal to f of y, you see how the orientation changes. That is, if we replace x with y, the graph also changes its orientation. The axis of the graph changes. Now we will plot some simple expressions in DESMOS. Some simple expressions like we will plot an ordered pair 3, 0. If we want, we can label it. We can click on label. We can add this point, say this is, and this point is A. So this point will be shown like this. Now suppose if I want to plot 2x plus 1, this is a straight line of y is equal to 2x plus 1. Suppose I want to plot y is equal to x square minus 4. Oh sorry, whatever I typed, x square minus 4. So this is a parabola. Suppose if I want to plot f of x is equal to twice of 2 raised to the power x. So this is a kind of asymptote. This kind of function is called asymptote. This one, f of x is equal to 2 raised to the power x, is a kind of asymptote. Suppose if I write x square plus y square, x square plus y square is equal to 3 square. So this gives me a circle. Now suppose if I write ordered pair r comma theta. So writing ordered pair r comma theta, automatically the software will understand that we are working on the polar coordinates. So automatically it will, sorry, I have to change the from arrows, that is from grid. The grid reference was like in polar, so I change it to now grids, that is the horizontal and vertical. So whenever we will write r comma theta, the software will automatically understand that it is a polar coordinate. So suppose I want to write r is equal to 3 cos of 5 theta, suppose. So this is r is equal to 3 cos of 5 theta from 0 to pi. So this is the figure that will obtain. Let me switch this off and this one off. So this is the figure that will obtain for r is equal to 3 cos 5 theta. Now suppose again that same thing, if I plot cos t and sin t, I can get a circle over here, ordered pair cos t comma sin t. I get an ordered pair from 0 to pi. This is a circle. This ordered pair will give me a circle. Now let's talk about integration. Integration is very important in the syllabus. So let's talk about integration. Suppose we take a function f of x is equal to 1 by 10th x square plus 1. This is a parabola. As you can see, this is a parabola. Suppose I want to make the integration, so I will write I and t integration. The lower bound of the integration is 0 and the upper bound is 4, and I make the integration of fx. Now this is fx. I want to make the integration of fx dx. So you see automatically the answer that will be appear. It is give the whatever the answer is, it will be appear over here. Similarly, if I change the bound for 2, then the answer will also change. Suppose I can change here also. I can, instead of 0, I can make 1. The answer is changing. Now suppose what I will do, instead of writing the upper bound and the lower bound, I will write here as a and I will write here as b. Means I am giving some constant, and this constant will come from a slider. So if I do the slider, see, as the value of a and b are changing, the value of the integration is also changing. We can add a point also, like suppose means I am not sure about this. We can add point also such that it will move along with the graph between which the integration is to be done. I will make another video on this topic. It can be done. I have not prepared that material for as of now, but it can be done. So I will make this video. The next video will be upon all this kind of things. Actually this can be done, but I have not prepared the material for that to speak, that's why. Now we will see about polygon. What is polygon? Suppose I define a point. Suppose see polygon. The polygon can be made by using the polygon formula. So suppose I want to make the polygon from the set of data points is like -2, 2. The second data point is 2, 2. The third data point is 0, -2. So this gives me a circle, sorry, triangle. This makes me a triangle because there are three sets of data points. As you can see, there are three sets of data points, so this is forming a triangle, and since it is polygon, so inside of it will be colored. We can also make the we can also assign the points like capital A is equal to we can say this point, sorry, capital A is equal to this point, we can label it also, and capital B is equal to this point, we can label it also. Okay, similarly capital C is equal to this point, we can label it also. So these are also the technique of making the points. And if I, instead of writing polygon like this, I can also write capital A comma capital B comma capital C. That also will suffice the work, that also will do the work. So this is how a polygon can be made. Also we can make the polygon using the by using the data features. That is, if I carry the data from outside, suppose these are the set of my x and y, I want to plot this as a polynomial. I will take it, I will switch this off first, all these things will be switched off. I will paste my data over here. Since the data is x1 and y1, so what I will do, I will write polygon, 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 the data x1 comma y1. Yes, this is forming a polygon. As you can see, it is getting crisscross. Maybe there are some mistakes with the point, it is getting cross, but it should have come perfectly. I have to check why this is coming cross. Maybe due to the problem with the data set. I think I have taken the wrong data set. But like this, if you take the correct points, then a correct polynomial can be developed using this function. Now we will discuss about some points around the function, around some circles and polygon, like say suppose I have to draw a circle. What I will write, ordered pair a cos t comma, sorry, not a cos t, it's just cos t sin t, and from 0 to 2 pi. So this is a circle. Now this is looking like oval just because the grid lines are not in a perfect square. So to solve this, we need to open another blank graph and write over here, that is cos of t comma sine of t, and this is from 0 to 2 pi. So this is forming a circle. Very nice, the circle is formed. Now another I want to plot as cos 2 pi from cos 2 pi, that is from 1 to n. Again here I will, in the denominator I have to give n, and here I have to multiply it with sine. The same argument will copy over here, the same argument, this one, and I will add a slider for n. As I will add the slider, let me see it is working or not. I think I have to give in here comma. I think I am not sure on this topic because these things are not into general practice, but I thought to make the video so as to the viewer may understand some basic concepts, that what all things can be done using this software. But I think this feature, this functionality is not working with this feature right now. Suppose n equal to 8 if I set. Nothing is happening. Wait, let me something this is something, there is problem. It is saying that cannot store a list of numbers in a list. So there is something problem. Let me take some other values. This kind of troubleshooting has to be done. This is also a part. So let's see. No, this is not happening. I don't know. I have to check it what is happening with this. So maybe in the next videos I will explain all these things. Thank you for watching my video. That's all for today. We have covered almost all the basic topics of DESMOS. In the first tutorial I have discussed all the basic topics that are needed to understand and draw the plot of any function in DESMOS. In the second video I have discussed some advanced functionalities which can be done after knowing the basics, but these advanced functionalities are not used every time, but still it is good to know. That's why I discussed. In my next coming video I will discuss about the parabola and hyperbola. So the next video will be on the parabola, that is how to work with the parabolas, how to develop a parabola, what are the components of the parabola, all the derivations and everything by using the DESMOS. So the next video will be on parabola. Thank you. Please subscribe to my channel and please hit the like button and please keep watching my videos. I will bring such kind of mathematical and ICT videos on a daily basis. Thank you.